Good afternoon from NASA's Kennedy Space Center in Florida. I'm Stephen Clark, editor of spaceflightnow.com, and welcome to our live coverage of the launch of a SpaceX Falcon 9 rocket with the SES-22 communications satellite. Liftoff is now 1 hour and 12 minutes away. Launch is scheduled for 5:04 p.m. Eastern Time or 21:04 UTC. SpaceX has a 2-hour launch window this evening in case of any technical issues or weather issues that could prevent launch at the opening of the window today. You're looking live at Space Launch Complex 40, a few miles away from our position at the Kennedy Space Center, where a Falcon 9 rocket is now vertical and is counting down to liftoff this afternoon. The rocket stands 229 feet tall, or about 70 meters in height. And this will be the 27th SpaceX launch of the year. So we're approaching the end of the first half of 2022. And assuming this mission gets off the ground today or tomorrow, that will be 27 Falcon 9 launches SpaceX has accomplished, all successful so far this year. On pace for more than 50 Falcon 9 launches this year. That would be a record for SpaceX. So a very busy first half of the year with no sign of any slowdown ahead. 2 more Falcon 9 launches are scheduled from here at Cape Canaveral in the first half of July, along with one out of Vandenberg Space Force Base in California. The next major milestone in the countdown will be at T-minus 35 minutes, when SpaceX's launch team should get a go, if all weather and technical parameters are green, for the start of propellant loading. And about 1 million pounds of kerosene and liquid oxygen will be loaded into the 2-stage Falcon 9 for this afternoon's launch. T-minus 58 minutes and 15 seconds and counting. You're continuing to look at a live view of Space Launch Complex 40 at Cape Canaveral Space Force Station, where the Falcon 9 rocket remains in place, awaiting liftoff at 5:04 p.m. Eastern Time, or 21:04 UTC. The rocket stands 229 feet tall. The lower two-thirds, roughly, of the vehicle is comprised of the first SpaceX missions before. You will notice that a lot of the booster stages are darker, with soot and markings from numerous flights to space. The record so far is 13 flights for a Falcon 9 booster, but this is a relatively young member of SpaceX's fleet going to space for the second time. So just a few markings there from its previous mission back in May from the reentry. The upper stage of the Falcon 9 is new, as it is for every Falcon 9 mission. It's the only significant part of the vehicle that's not recovered and reused. And then on top of the Falcon 9 is the 43-foot tall, roughly 17-foot wide payload shroud. That's the payload fairing that contains the SES-22 communications satellite. That's the sole customer, the sole payload for today's mission. The spacecraft weighs nearly about 3.5 metric tons. That's about 7,700 pounds, fully fueled for launch, and is on the way to a position in geostationary orbit over the Pacific Ocean, over the equator, at an altitude of more than 22,000 miles, or nearly 36,000 kilometers. And in that position, it'll be providing C-band TV broadcast services for customers, millions of customers across the United States. On the left side of your screen is an artist's illustration of what the satellite looks like. In this illustration, there are actually two satellites. SES ordered two virtually identical satellites, SES-22 and SES-23, from Thales Alenia Space back in 2020. And these are what these satellites look like. SES-22 is the satellite scheduled for launch today. SES-23 was built as a spare, and it may or may not be assigned to a future launch. Right now, there are no firm plans to launch that spacecraft, but SES reserves the option to launch it if needed on a future rocket. SES-22 was manufactured again by Thales Alenia Space in Cannes, France, and was delivered to Port Canaveral by boat back in early May, alongside another Thales-built satellite, NowSat 301, which launched on a Falcon 9 rocket back on June the 8th. Both of these satellites were shipped in separate containers on board this cargo vessel that arrived at Port Canaveral, and then the satellites went to a payload processing facility to be tested and fueled for their launches. Again, NowSat 301, an Egyptian satellite launched of similar size to SES-22, launched back in early June, and SES-22 is scheduled to launch today. This particular satellite is going up to geostationary orbit to provide C-band TV broadcast services. This is the first of 5 C-band TV broadcast satellites that SES plans to launch this year on 3 different rockets, 2 Falcon 9s and 1 United Launch Alliance Atlas V rocket. And these satellites are replacing C-band capacity that's been reassigned by the Federal Communications Commission to 5G terrestrial cell operators. And as part of that whole plan that the FCC has put in place a couple of years ago, big satellite companies like SES have ordered new satellites and will be reimbursed for these expenses to allow for part of the spectrum that the satellites were using for broadcast services to be reassigned to terrestrial cell service. We spoke with Christophe Hauer, who is the Chief Strategy and Development Officer for SES based in Luxembourg, a couple of days ago about this mission, and we're going to show you our chat with Christophe now.
Okay, Christophe, first of all, thank you for joining us for our coverage of the SES-22 launch. Can you tell us a little bit about the SES-22 mission and what kind of services it'll provide?
Yeah, sure, and thank you for inviting me here. So SES-22 is a C-band satellite, so it's part of our program of the C-band clearing in the US. So it's C-band only satellite. It will be launched at 135 West, which is the location, this is a location that we are replenishing, and from where we will then provide mostly TV and radio services over the US, but also some bit of data services over the country.
Can you tell us a little bit about how this satellite fits into the whole for the 5G transition, and also a little bit of background on why that's happening?
Yeah, sure. And so today we're using the full 500 megahertz of downlink C-band with the FCC order that was issued early 2020. We have to repack the services in the upper 200 megahertz. So all the services that we are providing, that we're currently providing, that we used to provide into the 500 megahertz, we will need, as from end 2023, to provide those in the upper 200 megahertz. Actually, today, we already done the phase one of the clearing. So the lower 120 megahertz have already been reallocated to terrestrial usage, to 5G. But now with the phase two, it's the entirety of the 300 megahertz being repacked that need to be free up, and so we need to provide everything in the upper 200 megahertz. So while for phase one, we were able to repack our customers using the existing fleet by compressing some services, by reallocating, moving services between different slots. For the phase two, which again is much more dramatic, so instead of freeing up 120 megahertz, it's freeing up 300 megahertz. For the phase two, due end of 23, we have to launch new satellites. So we have to have more satellites in the sky so that we then spread, if you want, the loading on a larger base of satellites as opposed to what we have today. So this is how it fits in. We will launch 5 satellites for the C-band, 5 C-band satellites. They're all going to be launched this year, hopefully. This is certainly the plan. And with that, we will be good. So that's the capacity we need in the sky in order to do the repacking.
And this is the first of those 5 satellites, which were kind of developed on a rapid timescale for a large geostationary satellite, right? They were ordered just 2 years ago, and now we're here on the precipice of the first launch.
Absolutely. So this is the first, indeed. SES-22 will be the first to be launched. We have SES-20 and 21 that will be the next one to go in Q3, and then we have the last 2, so SES-18, 19, that will be launched in Q4. So yes, those have been built quickly. This was the whole. We needed that. So those are not super large satellite. It's C-band only, right? So it's not massively big satellite, but it's still just geostationary satellite. So one of our main criterion for selecting the different vendors is what will be the timeline for them to deliver the spacecraft. Timing is everything in this program. We need, once the satellites are launched, we then need to move the customers around, and when the customers are being moved, then we can do all the last phase of filtering. So this still requires a bunch of time. So we needed to have the satellites being launched sufficiently early enough so that we could meet the deadline of end 2023. And for those satellites to be launched early, the first thing that we needed is that build quickly. So Thales managed to build the satellite in 22 months. Which again is, it's a great achievement.
And can you tell us a little bit about these this particular satellite, SES-22? It's going to be providing television broadcast services over the U.S., as I understand it. From the launch up until the spacecraft enters operations, can you kind of walk through some of the major activities on the spacecraft, and when will SES-22 actually be entering service?
Sure. So the launch should take place hopefully in a couple of days, on the 29th, on Wednesday, 29th of June. Then there is in-orbit raising. It's a chemical propulsion satellite, so the in-orbit raising is only a few days. Then we're going to do the testing of the satellite. The testing will be done further west in the arc, so not in the final location of the satellite, not at 135 west, going to be done in 142 west. So this is where we're going to do then all the in-orbit testing of the satellite. And when all the systems will have been tested, we'll drift the satellite to its final position at 135 west, with the objective to start then commercial operation early August of the satellite. So that's the plan. And as you said, the main mission of the satellite is for television, it's for cable feed. So there are a lot of cable system in the US that are being fed by satellite. Actually, close to all of them are being fed by satellite. So once the satellite is in operation early August at 135, we can then move some of those programming to 135, therefore freeing up capacity in the lower band on the other satellites.
And what happens to the satellites that are currently in orbit providing C-band services? Are those going to be phased out or retired, or will they still be of some use to SES?
No, we need those. We need those. So we need absolutely everything we have in C-band in order to do this repacking in the upper 200 megahertz, which is massive endeavor. We need all those satellites. So they will continue to operate as they're operating today. We will even replace, as part of this program, I was talking about the 5 satellites that we are launching this year. Some of the programs are designed to actually replace some of the aging C-band satellites that we would otherwise not have replaced. But because of the repacking, we need to replace those. So, but everything that's up there in C-band is used and will be used for us to continue to provide services to our customers.
I think all of these C-band satellites are going to be launched from here at Cape Canaveral, Florida. Can you talk about, this launch is going up with SpaceX. What are the next 4 C-band satellites going up on?
Yes, you're right. They're all going up from Cape Canaveral. So we have actually 3 launches. It's 5 satellites, but it's only 3 launches. This first launch now on Wednesday is a single launch. So 1 SpaceX, 1 Falcon 9 SpaceX rocket for 1 satellite being the Thales SES-22. Then the next 2 launches are dual launches. So we have the next one, which is a launch of SES-20 and 21. Dual launch, so the two satellites being stacked to each other and being launched on ULA. So it's Atlas V launch. We are using this rocket. This rocket is the right rocket for that specific mission. Those Boeing satellites are 702 SP, so electric propulsion, which means that in order we could not afford an in-orbit tracing of a number of months. Again, timing is everything for this program here. So it has to be close to direct injection. So the satellites would be almost immediately in geostationary orbit, and that required the Atlas V from ULA. So this is what we will launch next in Q3 with the SES-2021. And then the last dual launch is the launch of the 2 Northrop Grumman satellites, SES-18 and 19. Those are chemical propulsion and will be launched again with SpaceX Falcon 9 SpaceX rockets.
And Christophe, in addition to these C-band launches, you have another program, O3B mPOWER, that'll begin deploying later this year. Can you talk about that mission, how it's different from the C-band mission, and when those will begin launching?
Yeah, sure. So that's also very exciting. It's very different, as you say. So our mPOWER mission is MEO, Middle Earth Orbit. So it's not geostationary. It is actually our 2nd generation of Middle Earth Orbit. So after our 1st generation, which was the O3B constellation, we are launching mPOWER. So next generation satellites with much more capabilities than the current generation of MEO. So it's being launched at 8,000 kilometers. We are launching 6 of those satellites still this year. So very busy schedule this H2 for SES on the launch side. So in 3 different launches. So we'll have 3 times two satellites. All of them will be launched later this year, as I said, from Cape Canaveral or on the SpaceX. So they're very excited about that as well. The main, this is not about video. Again, it's middle Earth orbit. It's not about video, unlike SES-22 that we just talked about. This is for data customers, so addressing maritime, cruise, government, enterprises, low latency, high throughput connectivity. So very excited about that as well.
Okay, Christoph, thanks for joining us and good luck with the launch.
Thank you very much, Stephen, and thanks a lot for your interest in that. Thank you, appreciate it.
That was Christophe de Houwer, the Chief Strategy and Development Officer for SES. SES is one of the largest traditional satellite operators, geostationary satellite operators in the world, alongside Intelsat and Eutelsat, sometimes called the Big Three of geo operators. And today's mission for SES will be to deliver the SES-22 TV broadcasting satellite to geostationary orbit. The Falcon 9 will actually be delivering it to a geostationary transfer orbit, an elliptical or oval-shaped orbit. We just heard from SpaceX Launch Control that the pre-launch, pre-tanking pole is now open. So members of the SpaceX launch team down at the Launch Control Center that they use for Pad 40 launches near the south gate of Cape Canaveral Space Force Station are being polled electronically for a go or no-go to proceed with propellant loading and launch this evening. We haven't heard any update on any technical issues that are being worked right now. No word on that. So the countdown appears to be clean so far this afternoon. We're also awaiting news on the weather conditions. It's overcast over the Space Coast at this time, with some rain showers and thunderstorms off the coast. No rain in the immediate vicinity of the launch site at this time, but the launch weather officer from the 45th Weather Squadron, part of the range safety team from the U.S. Space Force, will be monitoring these clouds for any threat of lightning in the area. And lightning is a big no-no for rocket launches, so if there's any lightning strikes or even any detection of electrical charge, any significant electrical charge in the atmosphere, the range will be red for weather. So teams will be monitoring these weather parameters throughout the countdown to make sure all is safe for launch this afternoon of the Falcon 9 rocket. The Falcon 9 has a launch window today that extends for 2 hours, opens at 5:04 p.m. Eastern Daylight Time, or 21:04 UTC. And once again, to recap, this poll is now underway. We expect to hear the outcome of that poll in a couple of minutes, and propellant loading is scheduled to begin at T-minus 35 minutes, less than 5 minutes from now, if the poll is indeed go for launch. SpaceX's countdown now approaching T-minus 38 minutes. And the critical time of the start of propellant loading is scheduled for T-minus 35 minutes. And that's also when the countdown sequencer, the automated sequencer that governs all the countdown parameters, will take control of the countdown sequence. And after that, the entire countdown sequence will be controlled by computer. We're continuing to stand by for the news on the outcome of this electronic poll of SpaceX's launch team down at the control center just south of the pad, a few miles south of the pad, near the southern gate of Cape Canaveral Space Force Station. In the meantime, you're continuing to look at a live view of the Falcon 9 on Space Launch Complex 40. On each side of the vehicle are these 4 lightning protection towers with the aircraft hazard lights flashing. As you can see, it's a little bit of a gray day here with some overcast clouds hanging over the launch pad and some
venting for propellant load.
Dark clouds in the distance. We just heard a call out that tanks are venting in preparation for propellant load. That's again scheduled to begin in less than 2 minutes.
On countdown net, poll is complete. All go for propellant loading and launch. A reminder on abort instructions. For non-urgent no-go conditions, brief CE or LD and they will approve aborting the countdown. For urgent issues affecting the safety of the operation, operator shall call hold on the countdown net. Launch control will abort the launch auto sequence immediately and proceed in the launch abort auto. At T-minus 10 seconds, launch control will be hands-off and relying on automated abort criteria for the remainder of the count. And as a reminder, there is no recycle attempt today. We will be making one run for the window opening.
Launch auto sequence has started.
The countdown is just past the critical T-minus 35-minute point. And you heard a few moments ago SpaceX's launch director reporting the result of that go, no-go poll. And the result was go for launch, go for propellant loading. All parameters right now are green. And the launch director also confirmed that with the start of propellant loading, the launch window, which extended for 2 hours, effectively shrinks down to an instantaneous window. This, we believe, is because of the constraints with conditioning the densified propellants. Each team needs to load these propellants and then launch quickly to ensure the the propellants remain cold and at the right temperature for good performance from the Merlin engines on board the Falcon 9 rocket. Now inside of 34 minutes until launch. This mission is carrying the SES-22 communications satellite into orbit, and the rocket will be heading on a trajectory east from Cape Canaveral to target that equatorial orbit for this mission. T-minus 32 minutes and 17 seconds and counting. Here's an overview of the major events for this countdown this afternoon. The countdown is now past these first few milestones. We heard a go for propellant load from the launch director, and kerosene and liquid oxygen are now flowing into the vehicle. That began at T-minus 35 minutes in conjunction with the start of the auto sequencer, the computer sequencer that governs the countdown. Right now, kerosene fuel, this rocket-grade kerosene, is being pumped into the first and second stages of the Falcon 9 rocket out at pad 40. And liquid oxygen, the cryogenic oxidizer, chilled a few hundred degrees below zero, is also being loaded, but right now only being loaded into the first stage of the Falcon 9. At T-minus 16 minutes, the second stage liquid oxygen, or LOX tank, will begin loading. And then in the final 10 minutes, there are a variety of checks and verifications that are being performed and configurations on the rocket in those final moments of the countdown. At T-minus 7 minutes, the Merlin 1D engines, there are 9 of them on the bottom of the first stage, will begin to be chilled for launch. This is a procedure to thermally condition these 9 engines by flowing small amounts of super cold propellants through the plumbing and through some of the lines leading into the propulsion system, and that will condition those hardware elements for the flow of propellant at engine start. At T-minus 5 minutes, we expect to hear the call out that the kerosene tanks on board the Falcon 9 are full. About 46,000 gallons of kerosene, or RP1 fuel, will be loaded today. Around the same time, there's a checkout of the destruct system, or the flight termination system, on the Falcon 9 rocket. That's the range safety mechanism that would be used to destroy the rocket and terminate the flight in the event of a major problem. At T-minus 2 minutes, the Falcon 9 should be fully loaded with its 1 million pounds of propellants. As I mentioned, at T-minus 5 minutes, that's when the kerosene tanks are loaded. The liquid oxygen tanks will be full at around T-minus 2 minutes. And then the last 60 seconds of the countdown, the flight computer will be commanded to begin the final pre-launch checks. The propellant tanks will be brought up to flight pressure and the vent valves will be closed. And the SpaceX launch director will verify their go for launch at about T-minus 45 seconds. And the ignition system on the bottom of this first stage of the Falcon 9 will be commanded to start the 9 Merlin engines at T-minus 3 seconds. And after those engines throttle up to full power and pass an automated health check, hydraulic clamps at the bottom of the rocket will open, and that will allow the Falcon 9 to begin its climb to space this evening with the SES-22 communications satellite. As I mentioned, the rocket will be heading downrange to the east over the Atlantic Ocean. This trajectory is necessary to target the equatorial orbit for the SES-22 mission. After deployment from the Falcon 9, about a half hour after launch, SES-22 will unfurl its solar panels and then begin a series of its own maneuvers over the coming weeks to reach its final position in geosynchronous orbit, 22,000 miles thereabouts over the equator, and then is scheduled to begin service, commercial television broadcast service, to the United States in early August. Now inside of 24 minutes until this afternoon's launch of a Falcon 9 rocket with the SES-22 communications satellite, you're now seeing some vapors appearing around the first stage of the Falcon 9 rocket. These vapors coming from the condensed air caused by the loading of cryogenic propellant into the first stage. Liquid oxygen, which is chilled down to a few hundred degrees below zero, is being pumped into that first stage at this time, alongside densified kerosene or RP1 fuel. RP1 is a highly refined hydrocarbon fuel similar to kerosene. And that mixture of propellants will be feeding the 9 Merlin engines on the bottom of the first stage during the first 2.5 minutes of today's ascent into space. And then we'll also be feeding the Merlin engines during their maneuvers to safely bring that first stage back to Earth, targeting a landing on a drone ship more than 400 miles, about 660 kilometers downrange to the east of Cape Canaveral in the Atlantic Ocean. Everything appears to be going well at this time for an on-time liftoff at 5:04 p.m. Eastern Daylight Time. That is 21:04 UTC for those of you watching and listening in other time zones.
Stage 2 fuel load complete.
Now approaching T-minus 20 minutes, you're now seeing a venting of gaseous oxygen from the strong back near the understage area of the Falcon 9. This is a normal part of the countdown here at T-minus 20 minutes, marking the completion of kerosene loading into the second stage, of the Falcon 9, and the start of the chill down conditioning of the liquid oxygen loading line that runs up the length of that strong back structure next to the rocket and into the upper stage. And this is a chill down conditioning to prepare those lines for the transfer of oxidizer into the second stage, which begins at about T-minus 16 minutes.
LD, this is MM on CD1.
Go ahead, MM.
Spacecraft is proceeding into internal power switch.
Understand. Spacecraft proceeding to internal power at this time.
And we just heard confirmation that the SES-22 spacecraft on top of the Falcon 9 is now proceeding into the switch to internal power. This is part of the configuration of the spacecraft for launch. It'll be operating on its own internal battery power and going off of the ground power supply for the rest of the countdown and the climb into space. After deploying from the Falcon 9, SES-22 will unfurl its solar panels and begin charging its batteries with solar energy.
LD, this is MM on CD1.
Go ahead, MM.
Spacecraft is on internal power and go for launch.
Copy. Spacecraft on internal and go for launch. Thank you.
Start a stage 2 LOX load.
T-minus 14 minutes and counting. The countdown just passed the T-minus 14-minute point. You're continuing to look at a live view as vapors build outside the first stage as the supercold propellants continue loading into the first stage. About 1 million pounds of propellant will be loaded throughout the countdown up until about T-minus 2 minutes, when those tanks will be secured, the loading systems will be closed off, and then in the final minute of the countdown, the tanks will be brought up to flight pressure. Today's mission with the SES-22 communications satellite will be heading on a trajectory toward the east from Cape Canaveral Space Force Station. This map shows the approximate ground track for this mission. The red bar shows the rocket will be heading east out over the Atlantic Ocean. Space Launch Complex 40 is labeled here, as well as the approximate location of the drone ship, a shortfall of gravitas, about, or actually a little more than 400 miles downrange. That's about 660 kilometers east of Cape Canaveral. That's where the booster stage will be attempting to land on the drone ship. The deck of this vessel is about the size of a football field, and this booster today will be attempting to land on that ship. The orbital target for today's mission is a low inclination orbit, a geostationary transfer orbit. The SES-22 satellite will be heading eventually to an operating post in geostationary orbit. That's a circular orbit about 22,000 miles or 36,000 kilometers over the equator. And to reach this equatorial orbit from Cape Canaveral, a rocket typically heads due east, and then is on a trajectory over the Atlantic Ocean, and then eventually it will cross the equator in the Atlantic west of Africa. And that is where the second stage will actually perform a second burn to place the SES-22 satellite into the proper orbit. This graphic from SpaceX shows some of the maneuvers that the booster, the first stage, will be making on today's flight. About 2.5 minutes after liftoff, the booster will separate from the second stage, perform a flip maneuver to orient itself into a tail-first attitude. It'll extend some 4 titanium grid fins, and then perform an entry burn lasting more than 20 seconds with 3 of the Merlin engines to slow down and guide itself toward its landing target. And then in the final minute of the descent, the grid fins will help steer toward the drone ship. And then the center engine of the booster stage will ignite for a final braking burn as 4 landing legs extend and the rocket settles onto the drone ship in the Atlantic Ocean. Here are the major events during today's launch. This is about a 33.5 minute mission from the time of liftoff until the deployment of the SES-22 communication satellite. The rocket will be exceeding the speed of sound in about a minute after launch. And then the first stage will shut down and detach, as that previous graphic showed, about 2.5 minutes into the mission. And the second stage will ignite for its first burn at T+2 minutes and 41 seconds. The payload fairing on top of the Falcon 9 will be shed at T+3 minutes and 24 seconds. The fairing will also come back to Earth under parachutes in 2 halves, and SpaceX has a recovery team downrange to recover those fairing elements from the sea for cleaning and refurbishment and reuse. The first stage will be targeting a landing on the drone ship about 8.5 minutes after launch. It'll actually fly over 100 kilometers in altitude at its highest point and then re-enter the atmosphere for this landing. In the meantime, the second stage will be completing its burn to place SES-22 into a preliminary parking orbit about 8 minutes after launch. And then it will coast across the Atlantic Ocean in that low orbit until T+27 minutes and 8 seconds. And that's the time that this second stage will restart for a burn lasting about 66 seconds to propel the SES-22 satellite into its elliptical transfer orbit with a highest point or apogee tens of thousands of miles, more than 20,000 miles actually, over the Earth. And that deployment of the SES-22 spacecraft is timed for T+33 minutes and 26 seconds. And that will be the conclusion of the launch phase of the mission, and then control teams over in France will take control of the SES-22 spacecraft for its commissioning and post-launch operations. Now back live with a full screen of Pad 40 of the Falcon 9 rocket 9 minutes from liftoff, now with the SES-22 satellite from Cape Canaveral Space Force Station. T-minus 7 minutes and 45 seconds. The booster, the first stage on today's mission, is a relatively young member of SpaceX's inventory of reusable boosters. It's booster number 1073, and it made its first flight back on May the 14th, carrying a batch of Starlink internet satellites into orbit, and is ready for its second flight today, 46 days later, with the SES-22 communications satellite. So this is a relatively young member of SpaceX's fleet of reusable Falcon 9s, and is again targeting a landing on the drone ship to come back to the port for refurbishment for future missions down the road.
Engine chill. Stage 1 RP1 load complete.
T-minus 5 minutes and 40 seconds. One of the major milestones a few moments ago was the start of chill down on the first stage engines. This marks the time when those engines begin to be thermally conditioned for ignition by flowing small amounts of propellants through the plumbing into that propulsion system. We've also heard a call out in the past few moments that the first stage has been fully loaded with kerosene fuel. So both stages of the Falcon 9 are now full of fuel. This rocket-grade kerosene will fuel the Merlin engines on the first and second stages of the Falcon 9 for this evening's mission. In total, about 46,000 gallons of kerosene has been loaded into the Falcon 9. Liquid oxygen continues to flow right now into both stages, and that will be terminated at about 2
Tanks
minutes
pressurized
before
in 4,
liftoff.
strong back retract.
The strongback structure that you see to the right of the Falcon 9 in this view has begun its retraction to an angle of about 1.5 degrees from the Falcon 9. This begins with the opening of clamps at the top of that strongback that reach around the upper stage of the Falcon. And then the gantry strongback begins its retraction, and if you look closely, you can see that movement underway at pad 40. Now inside of 3 minutes, 2 minutes and 35 seconds remaining until liftoff. This mission will be heading east from Cape Canaveral Space Force Station to place the SCS-22 communications satellite into a geostationary transfer orbit. This mission, this spacecraft, was built by Thales Alenia Space. It weighs about 3.5 metric tons, or about 7,700 pounds. And the Falcon 9 will send it well on its way toward an operating orbit about 22,000 miles over the equator. This spacecraft will be operating for about 15 years, providing C-band, cable TV, and radio broadcast services over the United States. 2 minutes until launch now. The Falcon 9 should be fully loaded with oxidizer and kerosene fuel at this time, about 1 million pounds of propellants on board for tonight's mission. And we've heard confirmation that the Stage 2 liquid oxygen load is complete. We heard a few moments ago that Stage 1 was also full. So confirmation the Falcon 9 is fully loaded with propellant for liftoff in 1 minute and 26 seconds. T-minus 60 seconds. The Falcon 9 is now in startup mode. The onboard computer now in control of all the countdown functions. T-minus 45 seconds. T-minus 30 seconds. T-minus 10 seconds. T-minus 5, 4, 3, 2, 1. Engine ignition. And liftoff of SpaceX's Falcon 9 rocket from Cape Canaveral Space Force Station, carrying the SCS-22 communications satellite toward geostationary orbit on a mission to provide TV broadcast services over the United States. Now T plus 90 seconds, the Falcon 9 has faded from view through the cloud cover here at Cape Canaveral, Florida, and is now pitching downrange. We're switching over to SpaceX's feed, which I'll caution you comes with a bit of a delay, about a 20-second or so delay in this feed from SpaceX from an onboard camera looking aft or toward the rear, back toward Earth as the Falcon 9 heads downrange heading east out over the Atlantic Ocean. Good engine performance reported so far from SpaceX, and the trajectory is reported to be nominal as well. And we've seen confirmation now of stage separation. On the left-hand side of your screen, the first stage has extended its grid fins. And on the right, the upper stage engine is firing to place the SES-22 spacecraft into a preliminary parking orbit. And there's confirmation now of fairing separation now that the upper stage is in orbit, or in space rather, on the way to orbit. That payload fairing has jettisoned in two halves. The fairing will come back to Earth under parachutes and will be recovered from the ocean with SpaceX recovery boats. Now more than 5 minutes since launch, continuing to watch a split screen from SpaceX. Again, this is coming with a delay of about 25 seconds or so. 2 onboard cameras on the first stage of the Falcon 9. On the left, you're looking toward the rear of that booster with those 4 titanium grid fins extended to aid in the descent. On the right, the Merlin vacuum or MVAC engine on stage 2 glowing red hot. This is normal, as it fires with more than 200,000 pounds of thrust to place this SES-22 spacecraft into a parking orbit. And now we see visual confirmation of the entry burn on the left-hand side of your screen. 3 Merlin engines firing to slow down the rocket. You can see the velocity meter in the lower left-hand part of your screen decreasing. And this is to slow down the booster as it enters the lower, thicker layers of the atmosphere. And there's entry burn shutdown. And those coal gas thrusters pulsing to help control the orientation of the booster as it heads down deeper into the atmosphere. It'll be passing through another period of maximum dynamic pressure on the way in, and will be going subsonic just before it ignites its center engine for a landing burn. We've heard verbal confirmation from SpaceX's launch team that the first upper stage has completed its burn to place SES-22 into a parking orbit. And now on the left-hand side of your screen, you're watching an onboard camera view of the first stage booster coming through the clouds, heading for the drone ship, a shortfall of gravitas, that drone ship now in view. That center engine throttling to control the descent rate. And there is a bullseye landing for booster 1073, completing its second trip to space. After a good landing on the drone ship, a shortfall of gravitas, parked about 400 miles east of Cape Canaveral. You're now watching views from the upper stage, which is now in its on-target preliminary parking orbit at an altitude of about 167 kilometers and a velocity of nearly 27,000 kilometers per hour. And this upper stage will be coasting in this parking orbit until T plus 27 minutes approximately, when it will reignite for about a minute-long burn to send SES-22 into a higher orbit, an elliptical geostationary transfer orbit. That burn will last again about a minute and do a lot of orbit raising for the satellite toward its operating altitude of 22,000 miles or nearly 36,000 kilometers. Now a little more than 12 and a half minutes since the launch of the Falcon 9 rocket from here at Cape Canaveral, Florida, with the SES-22 commercial television broadcasting satellite. The second stage, as you can see on this map provided by SpaceX, is about halfway across the Atlantic Ocean from Florida to the west coast of Africa. The first stage has landed on the drone ship a few minutes ago, and its position on that vessel is marked on this map as well. At T plus 13 minutes, we're also about 13 minutes away from, or 14 minutes away rather, from the restart of the second stage's Merlin vacuum engine. And this is a critical maneuver that's absolutely required to be successful for the SES-22 satellite to complete its mission. This burn will last about 66 seconds, and we'll do a lot of work to place the SES-22 satellite closer to its operating orbit. And then that will set the stage for deployment of SES-22, the only payload on this mission, at T plus 33 minutes and 26 seconds. T plus 21 minutes and 27 seconds. About 5.5 minutes remain until the ignition of the Falcon 9's upper stage. As you can see in this map, the upper stage is currently just crossing the coast of West Africa after transiting the Atlantic Ocean after liftoff from Cape Canaveral nearly 22 minutes ago. It'll be crossing over the Gulf of Guinea and then heading generally east-southeast over the southern part of the continent of Africa. On this map, you can see in front of the second stage on this track, you can see the two lines begin to deviate, a white line and a blue line. The blue line is the current orbit of the second stage if this upcoming burn did not happen. The white line is the new trajectory that will be reshaped and that the Falcon 9 upper stage will head off in after this burn. So you can see this illustration shows that this upcoming burn will actually raise the orbit and alter the orbit of the upper stage, and this is a critical maneuver to give the SES-22 communication satellite a boost toward its operating altitude. This mission is heading ultimately to an operating altitude of more than 22,000 miles, nearly 36,000 kilometers over the equator. This is called a geosynchronous or geostationary orbit, and it's the perfect altitude where a satellite's velocity moves around the planet Earth, at the same rate that the planet rotates. So it gives the spacecraft a view of a constant geographic region and also allows antennas on the ground that point up at the satellite to remain pointing at a fixed position in the sky. And this SES-22 spacecraft is beginning a 15-year mission providing television broadcast services over the United States, C-band services to be exact. And SES, the owner of the satellite, says this satellite, along with 4 others scheduled to launch later this year, will reach about 120 million cable TV homes in the United States.
Acquisition of signal, Gabon.
The Falcon 9's upper stage is now within range of a ground station in Gabon, just outside of Libreville, and this will be tracking the upper stage during this upcoming burn. Burn now 2.5 minutes away.
MVAC startup.
We've just heard confirmation, just past the 27-minute mark of the mission, that the MVAC or Merlin vacuum engine has reignited. This is a burn to place the SES-22 communications satellite into a higher orbit. You can see the velocity increasing as well as the altitude now. The Falcon 9 upper stage now in a night pass over Africa, and the engine bell glowing red hot from this superheated exhaust coming out of the Merlin vacuum engine. This is normal. About halfway through the burn at this point. This burn is supposed to last about 66 seconds, and this engine is producing more than 200,000 pounds of thrust. It's a rather powerful engine for an upper stage. Velocity passing 31,000 kilometers per hour.
MVAC shutdown.
We've heard audio confirmation of MVAC engine shutdown. This video is coming with a bit of a delay from SpaceX's onboard cameras. We should see that shut down momentarily. And there is visual confirmation of engine shutdown. The second stage reached a peak velocity of 34,837 kilometers, according to SpaceX's telemetry readout. Now about 5 minutes until spacecraft deployment.
Acquisition of signal, hard to be suck.
Falcon 9's upper stage now in range of a communications tracking station in South Africa. About 2 minutes remaining until payload separation. Now less than 30 seconds from the expected time of spacecraft separation. You should see a good view of that payload deployment in this onboard camera view from the second stage of the Falcon 9.
Payload separation confirmed.
And we've had verbal audio confirmation from SpaceX Launch Control that the payload separation has occurred. And there you have it. SES-22 has been deployed from the Falcon 9 rocket's upper stage. An excellent view as the two vehicles coast over Africa. You got a good view there momentarily of the main engine, the liquid apogee engine on the SES-22 satellite. That's the engine that will be performing the rest of the propulsive maneuvers to configure and maneuver that satellite into its planned operating orbit over the equator.
Acquisition of signal, Mauritius.
Now 34 minutes since launch.
Expected loss of signal, Gabon.
And with that, SpaceX has concluded their live video broadcast for this evening's mission for SES-22. We did see a successful launch at 5:04 p.m. Eastern Time, or 21:04 UTC, from here at Cape Canaveral, Florida. And then about 2 minutes ago, we saw the deployment of the SES-22 spacecraft from the upper stage into what is expected to be an on-target orbit. No reports of anything amiss with the launch. Now that SES-22 is on its own, some of the next major steps will include the deployment of its solar panels. Here's what that deployment looked like during a ground test at the manufacturer Thales Alenia Space at their facility in Cannes in southern France. These solar panels will extend several tens of meters, roughly 100 feet tip to tip when fully unfurled in space. And here's what that deployment looks like sped up in this ground test. Has two solar array wings on each side of the main body of the spacecraft to recharge the satellite's batteries. During the launch sequence, SES-22 was actually operating on internal battery power, and it needs those batteries recharged now that the spacecraft is in space. This satellite is based on the Thales Spacebus 4000 satellite platform. And now you're looking live again at Space Launch Complex 40, where the Falcon 9 launched 36.5 minutes ago to place this satellite weighing about 3.5 metric tons, or about 7,700 pounds, on a path toward its operating position in geostationary orbit, more than 22,000 miles, or nearly 36,000 kilometers over the equator. SES-22, over the course of the coming weeks, will perform a series of orbit-raising burns to maneuver itself into this final orbit from the current elliptical, elongated orbit into a circular orbit over the equator. And then it'll finish up its antenna deployments and go through a round of in-orbit verification testing. And SES, the Luxembourg-based company that owns the spacecraft, says SES-22 should be ready to enter commercial service in early August, beaming television signals to customers across the United States. Earlier today, we got a great vantage point of 3 different rockets on launch pads here at Cape Canaveral Space Force Station. You see, this was the Falcon 9 this morning on pad 40 before it launched with the SES-22 communications satellite. The Space Launch Complex 40 is located at Cape Canaveral Space Force Station. Less than 2 miles to the north is Space Launch Complex 41, where ULA, United Launch Alliance, rolled an Atlas V rocket to the pad this morning in preparation for a launch tomorrow evening at 6 p.m. Eastern Time with a pair of U.S. military satellites. Further up the coast to the north at the Kennedy Space Center, SpaceX operates Launch Complex 39A, which it leases from NASA. Here you can see the construction on the right side of the Starship Orbital Launch Tower well underway, with 3 segments now lifted for the future home of the Super Heavy vehicle and the Starship vehicle in development by SpaceX. And then the northernmost pad here at the Cape Canaveral Spaceport is home to NASA's Space Launch System moon rocket in preparation for the Artemis 1 mission test flight to the moon. That test flight scheduled to launch in the late August timeframe, no earlier than late August. And that Artemis 1 moon rocket has completed testing out at Pad 39B in recent weeks, including a fueling test earlier this month, and is scheduled to return to the vehicle assembly building as soon as tomorrow evening, overnight tomorrow into Friday morning, for the final tasks and final steps of its launch campaign. Those will include a repair of a hydrogen leak that was found during that fueling test, as well as final testing of the flight termination system, the range safety system on the rocket, and final stowage of payloads that will be flying inside the crew cabin of the Orion spacecraft for this unpiloted test flight that NASA hopes will pave the way for future crew missions to the moon. With the SES-22 launch now in the books, we'll look ahead to what's next on the launch calendar. There are 3 missions scheduled for launch from sites worldwide, including 2 from the United States on June 30th. That's tomorrow. And in fact, the first of these is actually scheduled for tonight at 1 a.m. Eastern Daylight Time. Virgin Orbit's 5th orbital launch with the Launcher 1 vehicle. It's an air-launched rocket that will be dropped from the wing of a Boeing 747 carrier aircraft over the Pacific Ocean. This will be carrying 7 small satellite payloads into orbit for the U.S. military's space test program. These are experimental CubeSat-type payloads heading to low Earth orbit. The 747 carrier jet will actually be taking off from the Mojave Air and Spaceport north of Los Angeles, and then fly out over the Pacific Ocean near the Channel Islands to launch this 70-foot-long 2-stage liquid-fueled rocket on a trajectory toward the southeast from its drop point over the Pacific. And given clear skies and the nighttime launch at around 10 p.m. Pacific time, viewers and listeners in Southern California do have a chance to see this rocket as it begins its climb into space after release from the 747 carrier aircraft. It'll be dropped at a point roughly southwest of Long Beach, California. Also tomorrow is the launch of an Indian Polar Satellite Launch Vehicle carrying 3 small satellites for Singapore, including a military Earth observation satellite for Singapore. This will be launching out of the Satish Dhawan Space Center on the east coast of India. And then tomorrow, as I've mentioned earlier, the United Launch Alliance is scheduled to launch its 4th Atlas V flight of the year with the USSF-12 mission for the United States Space Force. This will carry 2 satellites into orbit for the U.S. military from Space Launch Complex 41 at Cape Canaveral Space Force Station. We showed you a view of that Atlas V earlier. The next SpaceX launch is currently penciled in for July the 7th from here at Cape Canaveral, Florida, from Space Launch Complex 40, the same pad we saw in action today. And this will be launching on the Starlink 4-21 mission with the next batch of SpaceX's Starlink Internet satellites. So we'll hope you'll join us for each of these launches. We'll be streaming and providing coverage for these missions on YouTube or at spaceflightnow.com. In the meantime, if you want to support our coverage, you can join and become a member of our YouTube channel. You can also go to spaceflightnow.com and become a member there through our membership tab at the top of the spaceflightnow.com homepage. And you can also contribute. You're welcome to contribute through the Superchat function on YouTube as well. We appreciate any contribution in any way that you can provide to us to help us bring you coverage like this and continue and expand what we do to bring live space events to you. With that, I'm Stephen Clark from spaceflightnow.com reporting live from the Kennedy Space Center. We'll be back tomorrow with several launches, including the next launch from here at Cape Canaveral in a little less than 24 hours with ULA's Atlas V. Until then, have a good night.